March 15, 1942, Detroit, Michigan. A bitter wind sliced through the skeletal streets, rattling the makeshift plywood barriers hastily erected around the city's factories. Inside the cavernous expanse of Ford's Willow Run plant, the air was thick with the scent of hot metal, welding flux, and the faint tang of gasoline. The echo of steel on steel reverberated through the hall like distant artillery. Hundreds of men and women moved in a carefully choreographed frenzy, their coveralls smeared with soot and sweat, faces lit by the orange flare of molten steel as massive fuselage sections began to take shape. You walk past the assembly lines, and the sheer scale of it hits you. The plant stretches farther than your eyes can follow, a labyrinth of scaffolding, overhead cranes, and conveyor belts that seem to pulse with life. Somewhere above, a row of engineers in crisp white shirts and rolled-up sleeves consults blueprints, shouting instructions that disappear into the cacophony. Each line worker is a cog in a machine larger than the sum of its parts. Each hammer strike can rivet a beat in a symphony of war production. It's here, in the heart of Detroit, that Henry Ford's vision collides with the imperatives of total war. The Willow Run facility, originally intended to churn out the latest Ford automobiles, is now being repurposed to produce one of the most complex machines the world has ever known, the B-24 Liberator bomber. The challenge is staggering. How do you take a plant built for Model Ts and transform it into a factory capable of delivering bombers by the hour? The answer, as the men and women on the floor are discovering, lies in relentless organization and the pioneering application of assembly line principles to an entirely new scale. Giant subassemblies, wings, fuselage sections, tailplanes, roll forward on tracks, guided by workers who have memorized sequences that would daunt even the most disciplined orchestra conductor. Sparks fly as rivets are pounded into place, and the whine of pneumatic drills blends with the hum of conveyor motors, creating a strange industrial music that is at once hypnotic and terrifying in its intensity. At 7 a.m., a hush briefly falls over the east wing. A complete fuselage section has emerged from the tooling area, a gleaming testament to precision and coordination. A foreman, his face lined from years of factory floors, signals with a gloved hand, and the massive cranes lift the section with painstaking care. Every movement is timed to the second. A single misstep could mean hours of delay or worse, a defective airframe that will never leave the ground. Outside, the city roars with life. Trucks loaded with engines, aluminum sheets, and instruments pour into Willow Run, dodging streetcars and civilian traffic, while nearby neighborhoods hear the constant drone of industrial effort. The workers barely notice. Some are former auto mechanics, others are typists, teachers, and even teenagers who lied about their age to join the effort. They have been trained to see not just the machine but the mission. Each bomber will carry men into the skies over Europe, a shield of American industry behind every flight. By mid-afternoon, a faint vibration begins to travel through the floors, a signal that another wing assembly has begun its journey along the moving line. In a corner, a young riveter named Martha glances at the partially completed wing with a mix of awe and fatigue, her gloved hands steady despite the blisters. She knows that at this rate, the plant will soon produce a complete B-24 every hour. The idea is almost unimaginable, a machine so massive, so complex, coming together with the mechanical precision of a Ford sedan, yet destined for the chaos of wartime skies. And somewhere in the mezzanine, an engineer named Carl scribbles notes furiously, adjusting tolerances and flow patterns in real time. "If we shave just 3 seconds off that riveting step," he mutters under his breath, "we can push the output to the next level. Every person here is a soldier in their own right, and the battlefield is made of steel, sweat, and ingenuity." As the first shadows lengthen across the floor, the sheer scale of Willow Run begins to make sense. It is more than a factory. It is a statement that American industry can be a weapon as potent as any gun or plane. And in a few short months, the entire world will witness the results of this audacious gamble. A bomber produced with the same relentless efficiency that once built cars, ready to tip the scales of war. April 2, 1942. Willow Run, Michigan. The morning fog still clings to the rooftops outside as you step into the plant, the air already vibrating with the rhythm of industrial creation. The once familiar automotive machinery has been replaced by towering jigs and fixtures, each one designed to shape enormous bomber components with the precision of a Swiss watch. The scent of oil and metal is heavier here, and the hum of the assembly line has grown into a low, constant roar, like distant artillery rolling across the fields of Europe. Inside, the transformation is astonishing. Where the Model T once rolled off tidy conveyor belts, massive aluminum fuselages now glide on wheeled dollies, guided by teams of men and women in sweat-streaked overalls. The walls are lined with storage racks brimming with wings, engines, propellers, and instrument panels. Components that, just a few months ago, were unimaginable to a car factory workforce. You notice a group of engineers huddled over blueprints, their fingers tracing the outline of a B-24's complex geometry, calculating stress points and rivet patterns with the intensity of battlefield generals plotting an assault. The changeover hasn't been easy. Ford's engineers had to reinvent the assembly line from the ground up, translating car-building principles to an airplane that stretches 110 feet from nose to tail and weighs over 35,000 pounds empty. Everything is modular now. Wings are built in giant subassemblies, tailplanes crafted on separate tracks, fuselage sections welded and riveted with incredible precision. The challenge is keeping these pieces moving smoothly through the plant without bottlenecks. A miscalculation could halt production for days. On the line, a young mechanic named Jimmy tightens the last bolts on a nacelle, his hands shaking from fatigue but his eyes sharp. Nearby, a welder named Louisa sparks arc after arc, melting seams into place while keeping an ever-watchful eye on the conveyor pace. They exchange terse instructions over the roar of pneumatic drills. Timing is everything. Every second counts because at this rate, Willow Run is poised to produce one B-24 bomber per hour, a figure that seems almost mythical when whispered over the hum of the plant. You follow the movement of a massive wing, suspended by an overhead crane. It lurches forward like a living creature, guided by 6 men below, each gripping the steel supports with gloved hands. The crane operator adjusts the hook with millimeter precision, lowering the wing into position for the fuselage attachment. Any misalignment, and the aircraft could be grounded before it even reaches the tarmac. The tension is palpable. Everyone knows the stakes. Each completed bomber represents not just engineering triumph, but lives, American and Allied, hanging in the balance. Meanwhile, Henry Ford himself occasionally appears on the mezzanine, observing the assembly with a keen eye. Though his face is lined with age, there is a spark in his gaze as he watches the workers orchestrate the symphony of machinery. His vision of mass production, a system that once made automobiles affordable for the masses, is now weaponized for war. Ford doesn't speak often. He lets the machines and men tell the story, nodding in approval as another fuselage rolls seamlessly into position. In the background, the plant's infrastructure hums with invisible coordination. Conveyors are timed down to the second. Cranes glide on rails overhead almost like synchronized dancers. Riveting machines feed automatically. Pneumatic tools hiss and thump in rhythm, and every station is monitored for efficiency. Engineers circulate with clipboards, constantly adjusting, improving, calculating. Every detail is a microcosm of war planning. You cannot afford error when production must meet the demands of a global conflict. By late afternoon, the pace reaches its peak. A full bomber, nearing completion, rests on its wheels for a final inspection. Its olive-drab fuselage gleams under the fluorescent lights, and you can almost feel the latent power coiled in its 4 Pratt & Whitney engines. Workers step back, wiping sweat from their brows, knowing that within the next hour, another fuselage will start its journey down the line. The rhythm is hypnotic, almost terrifying in its consistency. Willow Run has become a factory of miracles, and its product, a machine of destruction, is a testament to what human ingenuity, drive, and sheer determination can achieve under pressure. Outside, the Detroit skyline darkens as dusk falls. The roar inside Willow Run continues unabated, a beacon of industrial might, signaling to the world that America is no longer just a nation of consumers, but a nation of producers capable of wielding assembly line precision as a weapon. And in this massive dance of human effort and mechanical power, one thing is clear. The age of the bomber, delivered by the hour, has arrived. May 10, 1942, Willow Run, Michigan. The clang of steel greets the dawn as the plant comes alive once more. You step onto the floor and are immediately swept into a river of motion. Workers moving in perfect, exhausting synchrony, faces streaked with grime and determination. The B-24 line stretches farther than your eyes can follow. each station a carefully choreographed node in the intricate web of production. You realize quickly, this plant is not just about machines. It is about people, and their lives are as vital to the bomber as any bolt or rivet. Among them is Clara Thompson, a riveting specialist whose hands have memorized the rhythm of a B-24 wing better than any sheet music. Each rivet she hammers is an act of devotion, her muscles burning, her mind focused on nothing but the alignment, depth, and precision required. Around her, dozens of other women, many drawn from offices, teaching positions, and shops, move with similar focus. The plant is a testament to the power of Rosie the Riveter, women who can match and often exceed the skills of men, standing shoulder to shoulder in a shared mission of unprecedented scale. In the assembly bays, men like Corporal Jack Hensley, a recently discharged machinist, tighten fuselage panels with methodical care. His forearms glisten with sweat under the harsh fluorescent lights. He pauses for a moment, listening to the symphony of pneumatic hammers, welding torches, and the mechanical whir of overhead cranes. Each sound is a pulse in a living organism. And Jack knows that even a second of distraction could send a wing crashing into a fuselage, costing precious time. It's not just skill but endurance that Willow Run demands. Shifts run 14 hours long, and fatigue is a constant adversary. Yet in the midst of exhaustion there is camaraderie, a network of quiet encouragement and humor. Workers shout directions across conveyor belts, offer water and sandwiches, and exchange brief jokes that ripple through the tension like sunlight piercing a storm. The environment is grueling, but the collective determination transforms strain into rhythm. You move past the final assembly line, where fully completed B-24s are being wheeled toward the paint and armament bays. Here, Sergeant Walter Grimes inspects each fuselage meticulously. His eyes scan every rivet, panel seam, and control cable, trained to detect flaws invisible to untrained eyes. "One defect," he mutters, "and you might as well stay home." His words are not harsh, they are truth. Each bomber represents more than industrial achievement. It carries pilots, navigators, gunners, and bombardiers into the skies of war, and Willow Run cannot afford mistakes. In the mezzanine above, engineers constantly adjust and optimize. A young prodigy named Eleanor Kim watches her gauges, cross-referencing production rates with part delivery schedules. "If we shave 30 seconds here," she says, pointing to a pneumatic riveting station, "we can push the line to a bomber every 55 minutes instead of 60. Her suggestion sparks a flurry of action. Workers and supervisors immediately realign the process, moving in a dance of human and mechanical synchronization. Outside, the roar of Detroit traffic mingles with the distant whistle of freight trains delivering aluminum sheets and engine blocks. The plant's influence spills beyond its walls. Cafeterias and break rooms hum with conversation about production quotas, bomber missions, and letters from the front. Even as the city sleeps fitfully under blackout curtains, Willow Run continues, an industrial heartbeat, unstoppable, demanding, relentless. By evening, you can see the human cost etched in every face. Blisters, calluses, and exhaustion are worn with quiet pride. Each person here understands that their labor is part of a grander narrative, an audacious industrial mobilization designed to shift the tide of war. Here, men and women are not just building bombers. They are building the backbone of Allied air power, a line of steel and sweat that stretches across the globe, one B-24 at a time. And as the last rivet of the day is hammered into place, the plant doesn't pause. The machinery continues to hum, workers rotate, and the next bomber inches forward along the line. Willow Run is more than a factory. It is a testament to the capacity of ordinary people to achieve extraordinary feats when the world demands it. June 21, 1942. Willow Run, Michigan. The plant awakens to another dawn, the first streaks of sunlight reflecting off aluminum fuselages like steel lightning. Above the roar of the assembly lines, the faint hiss of compressed air and the rhythmic pounding of rivets create a pulse that seems almost alive. But while the human engine is crucial, the true marvel lies in the engineering genius that has turned chaos into precision, the assembly line itself. Here, the transformation from car production to bomber construction becomes most evident. Engineers like Thomas "Tommy" Collins oversee the movement of giant wing assemblies along overhead rails, calculating weight distribution and stress points in real time. The complexity is staggering. Each B-24 has over 2.3 million parts, from tiny screws to massive Pratt & Whitney engines. Every component must meet exacting standards and the assembly sequence must flow flawlessly. A single misstep could jam the line and derail the daily output. You follow a wing as it glides toward a waiting fuselage. The cranes lower it with painstaking accuracy, guided by a team of spotters shouting coordinates over the roar of machinery. Inside, workers brace the wing, riveting panel after panel while keeping their eyes on alignment gauges. Nearby, a technician monitors hydraulic lifts, making micro-adjustments to keep the line moving smoothly. This is the orchestration of thousands of moving parts, both human and mechanical, executed with the precision of a symphony. Ford's engineers have applied lessons from the automobile industry in ways never imagined. Modular construction allows entire fuselage sections, wings and tailplanes to be built simultaneously, then brought together like giant jigsaw pieces. Conveyor belts carry assemblies across vast spans of the plant, while pneumatic tools and jigs ensure that each connection meets strict tolerances. The result is a machine as much of process engineering as of metal and fuel, a B-24 born from the marriage of mechanics and methodology. In one corner, Eleanor Kim reviews her charts again. She notices a minor lag in the fuselage assembly area and immediately signals a shift supervisor. Within minutes, a team rearranges the line, smoothing the bottleneck and shaving precious minutes off the production cycle. At this pace, the dream of producing a B-24 every hour is no longer theoretical. It is on the verge of becoming reality. Meanwhile, in the armament bays, gunners' stations and bomb racks are installed with the same meticulous care. Sergeant Grimes oversees the work, ensuring that every control cable, hydraulic line, and sighting instrument meets exacting specifications. This plane will carry men into combat, he reminds the team, and every bolt counts. The weight of that responsibility hangs heavy in the air, but it fuels focus and precision rather than fear. The scale of Willow Run is staggering. You walk past a row of completed fuselages, each one stretching over 100 feet, each one destined to roar across the Atlantic and into enemy skies. Yet the engineers and workers see only the next step, the next rivet, the next lift. The plant is a living organism, and every individual is part of its nervous system, its heartbeat, its logic. As dusk falls, the plant begins a quiet crescendo. The last cranes lower wings into place, the final rivets of the day are set, and the conveyor belts hum with the promise of tomorrow's production. It is in this moment that the true miracle of Willow Run is apparent. Not a single person or machine, but the synergy of thousands of moving elements, all driven by a single goal. Here, industrial might and human determination converge to produce something that no single inventor, factory, or nation could have achieved alone. And as night settles over Detroit, the B-24s sit in near complete formation inside the plant, ready to roll onto the tarmac at first light. Each aircraft is a testament not only to engineering brilliance, but to the audacity of vision. A factory designed for cars, now producing the instruments of war at a pace that will astonish the world. July 15, 1942, Willow Run, Michigan. The first light of morning slants through the high industrial windows, catching dust motes that hang in the air like suspended stars. Inside, the hum of the assembly line has already reached its relentless pitch. Today, for the first time, the plant is poised to achieve the impossible, producing a complete B-24 Liberator bomber every hour. You can feel the tension in the air. Workers, engineers, and foremen alike move with a precision born of months of training, experimentation, and relentless effort. On the main floor, riveter Martha Delaney adjusts her stance, hammer in hand, ready to set the next row of rivets. Beside her, welder Louisa Vargas arcs steel into place, sparks scattering like fiery rain. Each motion is a practiced ritual, almost instinctive yet exacting in its consequences. Supervisors hover with stopwatches, noting intervals, monitoring flow, correcting any deviation before it ripples down the line. Every second matters because today, the promise of industrial history hangs on flawless execution. At 8:00 a.m., the first complete fuselage, wings attached and systems installed, begins its slow journey toward the taxiway. A group of engineers rides the crane controls, making micro-adjustments to lift points and balance, while workers below guide the plane with ropes and steel bars. Sergeant Walter Grimes inspects the final assemblies, calling out minor corrections even as the massive aircraft moves forward. His voice cuts through the roar. Alignment perfect, control surfaces locked. Let her roll. You watch as the aircraft edges onto the tarmac, its 4 engines awaiting ignition. Nearby, a team of mechanics hooks up the electrical systems, hydraulics, and fuel lines. The magnitude of it hits you. Just months ago, this plant produced cars. Now, in the span of hours, it is delivering flying fortresses, machines that will soar over Europe, carrying men and bombs into the heart of the war. Inside the plant, the assembly line does not pause. The next fuselage glides forward on its dollies and the dance begins anew. Jimmy Hensley tightens engine mounts while shouting instructions to his team. Eleanor Kim recalibrates gauges to account for the slightly heavier load of this aircraft. The choreography is perfect, human and mechanical elements moving in a symphony of productivity. As the second bomber begins to take shape, whispers circulate. 1 plane per hour. The industrial miracle is no longer theoretical. It is happening. Outside, the roar of engines signals the first test taxi. The B-24 shudders to life, its 4 Pratt & Whitney R-1830s spitting smoke and thunder. You can almost feel the power vibrating through the concrete tarmac. Pilots, carefully briefed and suited, climb aboard, checking instruments and hydraulics one last time. The plane taxis down the strip, the ground trembling beneath its weight, and then lifting off, its massive wings slicing through the morning sky, bound for the war beyond. Back inside, the line does not slow. Fuselages roll, wings attach, control surfaces are tested, engines mounted. The human and mechanical network that is Willow Run hums as if it were alive. Each worker a nerve ending, each machine a muscle. Hour by hour, the pace is maintained. By late afternoon, another B-24 rumbles into the sky. Another hour passes and another aircraft begins its assembly. 1 per hour. Impossible a year ago, routine today. And in this rhythm, the enormity of Willow Run's contribution becomes clear. It is more than a factory. It is a weapon in itself, an industrial force multiplier. Each Liberator that leaves its doors carries with it not just bombs and guns, but the effort, sweat, and ingenuity of thousands of Americans working in perfect concert. The world may never see the assembly line as they see the bomber, but its power is no less decisive. August 3, 1942, Willow Run, Michigan. The sun pours through the towering windows of the plant, illuminating a sea of olive-drab fuselages stretching toward the horizon. You can almost hear the heartbeat of the building, the synchronized hum of conveyors, the steady pounding of rivets, the whirring of cranes, each sound a testament to human ingenuity and determination. Here, the impossible has become routine. 1 B-24 bomber per hour, every hour, powered by the sheer force of coordination, courage, and innovation. Inside, the workers move with practiced precision, their fatigue masked by focus and pride. Martha Delaney hammers rivets with rhythmic intensity, while Luisa Vargas monitors a welding seam, sparks dancing around her like tiny fireworks. The assembly line flows seamlessly, a living testament to the principles Henry Ford pioneered decades earlier, now elevated to an industrial art form. Engineers consult blueprints and check gauges, foremen issue instructions, and sergeants inspect the final assemblies, all part of a vast, interconnected organism devoted to production at an unprecedented scale. The scale and efficiency of Willow Run are staggering. By the end of the month, the plant is producing more B-24s than all other American factories combined. The once impossible goal of mass-producing heavy bombers has been realized through innovation, modular construction, synchronized assembly lines, and the tireless effort of thousands of skilled men and women. In every rivet, in every perfectly aligned wing, there is a story of adaptation, sacrifice, and ingenuity. And yet, the significance of Willow Run extends far beyond industrial metrics. Each Liberator that rolls off the line carries with it the promise of protection and power, capable of striking deep into enemy territory while shielding Allied forces from harm. The plant has transformed the American approach to warfare, proving that industry can be as decisive on the battlefield as strategy or courage. It has set a precedent, showing the world that a nation's factories, if properly mobilized, can become weapons in their own right. Outside, Detroit hums with life, oblivious to the magnitude of what happens behind its steel walls. But the men and women of Willow Run know. They know that their labor is not just about metal and machinery. It is about tipping the balance of a global conflict. Each hour a B-24 rises into the sky, a symbol of industrial might and human perseverance. And in that rising, the legacy of Willow Run is cemented, a place where ordinary people, ordinary machines, and extraordinary vision converge to change the course of history. As the last rays of the sun fall across the assembly floor, a newly completed B-24 taxis toward the runway, its engines roaring like thunder. You feel the weight of what has been accomplished, a factory that once made cars, now capable of producing a bomber every hour, embodying the full potential of American industrial mobilization. Willow Run is no longer just a plant. It is a testament to what can be achieved when ingenuity, dedication, and purpose collide. In the years to come, historians, engineers, and soldiers will look back on Willow Run as more than a factory. It will be remembered as a crucible of innovation, a place where the rhythms of industry were transformed into instruments of war, and where the people who toiled day after day helped deliver victory from steel, sweat, and fire.